shortcoming, I guess. And today I want to talk about I will read the title, Introduction to Intrusive and Visual Profiling with focus on constrained environments. And this thing doesn't work. So thank you, but I will need to do it manually. So briefly about me, I'm Lukáš, and I mean, feel free to somehow politely interrupt me in the middle if you have some questions. I will try to answer them as soon as possible because we can forget the context. Or at least there in the how is it called, bottom right corner there is the page number. I'm not sure if you will see it because of the shining of the sun through the windows, through the how is it called, blinders, but whatever. So feel free with the questions and stuff like that. So I will talk about, as I said, visual profiling and how did I get to that. Like 7 years ago, one of my very first issues that I solved myself in my programming career was I did it with the help of visual profiler called nvtx. That's library from NVIDIA or something, and it helped me to find out let's say inefficiency in visual application or desktop application. Just basically, there were two threads. One was pushing to some queue, and then the second one was under mutex, and some condition variable or something was taking or popping those elements from the other side. And there was some kind of inefficiency. I don't remember the details, but I didn't manage to figure it out with let's say, it's called printf debugging, right? When you put like logs or writes to std out. Only after using this nvtx library and visualizing it in the, I guess it's called NSight systems or something, I finally saw the problem and fixed it later. So since then I really like visual profiling, and so that's why I will talk about it today. So that's it. So show the talk. So I planned to do it this way. I will describe, or I will introduce you to the already established frameworks and libraries and whatnot. As I said, nvtx by NVIDIA, Tracy is very famous, I would say, at least from my perspective, right? It's very famous profiler. Then I will only briefly touch what like perf and with combination with flamegraphs can do. It's basically another valid approach. And of course, there are many others. Basically, if you use your favorite search engine for those keywords like visual profiling and stuff like that, you will find many more. And once again, in my career, I've got, let's say, a problem that I wanted to solve with visual profiler in another company. And those things at my hands that I was able to use, like the nvtx, Tracy, and etc., weren't, I would say, they weren't sufficient, or they weren't, good enough to easily fulfill the task. So I will briefly talk about what were their shortcomings and why did I, but eventually I managed to, how is it called, to bend, I would say bend the Tracy to do the thing partially, but still it kind of, it wasn't bad, it wasn't good experience in my opinion. And for that, my particular, I would say, use case, I was thinking that, like collecting the traces of what's happening inside your application is a relatively easy task, right? So why not write my own library with this functionality? So that's how we will get, or that's how I got to the last point in my presentation. And this is basically just, introduction or just basic description of the library I was lately writing, which I call cxxet. So just to synchronize on those basic terms, application profiling, what does it mean? it's a process when you have, of course, you have some kind of application you are developing or you take care of, and you want to measure performance, right? Somehow you have many options like micro benchmarking and what else, like system tests and whatever. But if you have some particular, like let's say, problem, and you know it's somewhere in some kind of in some part of the application or a library, you can definitely use this technique. And as any other profiling, it's, you know, basically its purpose is to measure performance, find possible bottlenecks, and, you know, then you can think about how to remove them or how to fix them, stuff like that. There are some, I would say, very famous quotes. I guess I don't need to introduce you to them. Most of you or most of us will probably know them from our careers, right? So next term is non-intrusive profiling. So basically, that's what the perf does, right? It samples the application, or it's running somehow in accordance with kernel, and it samples your application's call stacks, collects the data, and then somehow, you know, you can call something called perf report, I guess, and it will visualize you like the most called function. Probably it will be sorted like in the descending order, right? So you will see the most called functions, or in which functions the most time was spent in. And that's one of the options, how to non-intrusively profile your application, right? Then you can, of course, do the basic, once again, on the Linux, in the bash or somewhere similar. You can do time my application, and you will see at the end something like x seconds and y, what's the second row? I don't know. Just basically, it will tell you how much time did your application took to run. And in general, those approaches mean that you just take your application as it stands, execute it under some outer tool, be it the perf, be it the time, or be it the profiler built in Microsoft Visual Studio. And the application unchanged is somehow instrumented, measured, and you have some kind of results at your hands, right? And you can process them or try to reason about stuff. The other approach, the opposite approach, I would say, is the intrusive profiling. A bit higher, okay. Sorry, hopefully this will be better.
Well, if you want, I have a microphone here.
Sorry?
I have a microphone here. The one I can do. I will show you.
I have this one, I guess. Miloš was writing something about camera that I should tilt it, you know. And how do I? Intrusive profiling, right? So just basically, it's the opposite of the non-intrusive, right? I guess you can even deduce it from the missing prefix non. No problem. And hi. And mode. And you just basically, it's very, very similar to the printf debugging, right? Because in both cases, you just put some pieces of code into your source code of your application, you know, run the measurement or run the test or trial or whatever. And then you decide based on the results what to do next, right? You will just basically, you said, let's assume you have an application that's loading a file, processing it, and saving the results, right? Those three phases. So first, in the first iteration, you would most probably go like putting one marker on the input or on the loading of the file. Second marker would be the processing, and the third marker would be something like writing the results right to the disk. And then you realize, okay, this, for example, the middle part took longer than I expected. So you refine, you enter the function, right? You, how is it called? Oh, how is the word? Sorry. česky to identifikovat. You identify potential, sorry. You identify potential, what can go wrong or interesting things that you think you should measure, and eventually you iterate until you reach to a few points or few places in your code that take longer than you expected or than you want, right? And then you have your candidates for refactoring, refinement, or whatever. Call it however you want. So that's it. That's the idea of intrusive profiling, right? Every time, of course, since it's C++, every time you need to recompile the application, right? In cases of interpreted languages like, I don't know what, like Python or what else, you just basically just run it, right? But in our world, you need to recompile it, run it, evaluate, right? Python or similar ones have it one step shorter. So yeah, and I wanted even to say that I didn't even get to the visual part, right? Be it visual or be it just the printf debugging, it's very similar, right? You can use the printf debugging not to only print some debugging info or stuff like that. You can even print times, spent in some parts, right? So you just basically, you are very like good enough with already a standard library to somehow intrusively measure performance, right? But as I said, in my experience, it's not so clear and it's not so, I would say, enjoyable as, looking at beautiful, or maybe not beautiful, but definitely visually more interesting, how is it called? Those timelines of stacked bars that represent, what's happening in your program. And that, of course, are very similar to call stacks. And so, as I said, the visual profiling means that you will take the results in some format or form, and you just basically pass them up to another tool. Most probably that would be, or available tools are, for example, even built in the Chrome, the browser is, if you put there exactly this, the Chrome / tracing, you will enter some kind of internal or internally, present UI. That's, where you can load the traces in one particular format and, play with them and, evaluate them. And it's very similar with the Perfetto UI. It's only a web service that's kind of free, it seems to me, which I kind of, started to like and use for this purpose. And of course, the opposite thing of visual profiling might be just basically, looking at the output, right? If the format allows it, for example, you will see that there's one that's definitely, let's say, human readable and mostly even understandable, but you wouldn't see, the relations and the differences, like how is the system, behaving in relatively to the other parts, right? That's what the visual application is for. So it's clearly visible. And there was a subtitle, right? There was constrained environments. And, that's the thing that I named this talk this way, like Introduction to Intrusive and Visual Profiling, focusing on constrained environments. But the problem is that the word constraint in this field, let's say computer science or software development or whatever, somehow is very tightly coupled with embedded world or systems or stuff like that, which is definitely not field of my expertise or my experience. I will tell you later how did I mean it, and it's kind of my kind of small, hopefully only small mistake that I chose this unlucky word, and so. And eventually, if there's somebody, most probably, like there's somebody who is working in embedded world, so I would be very, very happy to hear from you later. What, like, regarding my library, I will be presenting later, or even the established tools like nvtx. like if it's usable in your context or not, and how to, for example, how to adjust it or how to use it so you can get some meaningful results. So we are slowly getting to the, as I said, established tools, and starting with the nvtx. So basically, you have, it's very, very simplified, oversimplified, I would say. Example of usage of this particular framework or library. Just basically, sorry, that's the line numbers are missing, right? They are behind the left side of the screen. But hopefully you can see the second include, right? And on the, I would say it's the fifth, how is it called? Fifth line. You see the, I'm not sure if it's function or macro, but it doesn't matter. Just basically you call this thing, and it will create a marker for you through the RIII. It will, when it goes out of scope, right, it will be like the fifth line from the end. It will properly, terminate the marker or the tracer. And then in the middle, you see the nvtx free cons code range, blah, blah, blah. And you see it in a loop, right? And eventually, when you run this program, when you compile it with the proper includes and libraries and whatever, run it somehow. I will show you how. Oh, I have it here in 7 steps. So basically, the most interesting, right, beside the first 2 points, where you have links for the download of those frameworks or of this framework, and the third one too. You just basically compile it. That's the fourth one. Then you run it under the NSys utility or program or application with some parameter profile. Just basically, running NSys dash help. You will see like, I don't know how many, like few pages of description what it can do. So basically this way, that's how the NVIDIA's profiler works. You need to run this your application, which has already inserted, into which you already inserted some of the code. You need to run this run it under this program, and then eventually that's the fifth step. And as the second step, you just basically, I forgot to add there that you open the resulting trace in the GUI. You decide what you need to measure next, and you repeat until you are happy, right? Until you find something interesting, or you give up because everything's, somehow, whatever, somehow not as we expected, or you can do anything with that. It may definitely happen too. That's just a screenshot of the command line. How does it look like? If you remember, the code was really simple. It was like calling a function, generating one marker for the function, and then 6 times in a loop, sleeping, and the sleep was, once again, guarded by another marker, right? And this thing took like almost 2 seconds, I would say. And it itself writes some stuff to the console, right? Like where is the report located? Where was it saved? And and then you open the GUI, as I said. It was, I would say, if I remember correctly, it was the first point in the list back then, right? That's what you install that's what you will get if you install the thing mentioned in the first step. Just basically some application, somewhere in the file menu, you will click on something like open or import or whatever. Select the trace, and this is what you get. And I have already zoomed on it. Oh, it's very small. I can try to do one very risky thing. I can try to reopen it. Currently on my machine, and it will be something like this thing. And it's already saved there, so it's fine. I guess it will be. All right, so you will see something like you have this framework, even tracks or samples something like operating system related counters or whatever, and system calls and whatnot. I'm not sure. And basically somewhere there, this is the line nvtx. Do you see it? Hopefully. I'm not sure if I can enlarge this. So I guess it won't get any better than what was in the presentation. Oh, sorry. But basically, I will try to at least this thing. I will try to zoom in on this thing, and basically you will see there stacked bars, only 2 levels, but still, that's what we inserted in. That's what was inserted in the code. You will see there. Oh, it's now much more lighter. You will see just basically there. The sum function, which was I will scroll back into the source code, which is this thing on the line 4 or 5, right? It's the sum function. And then you have the second marker, repeated like 6 times. That's called loop iteration range and whatever. And that's exactly what do you see under this first bar, right? And you, as I said, basically you just, that's the first iteration in your process, right? You start with this, and then you somehow identify that maybe the loop or some part of your code isn't performing as well as you expected. So you focus on it and you add markers into the next function, and you just eventually build it to look like a pyramid, or how to call it. Just basically, you just increase the depth of these stacked bars, most probably. So that's how does the NVIDIA NSight looks like. And so we are here. And I guess you can imagine that I have only showed you like 1% of 1% of 1% of what it can do, what it is capable of. It can definitely trace more things in more different ways, and probably even visualize them in different ways and stuff like that. But I won't go into the detail. As I mentioned that in the past, one of the first, my successes in my career, I would say, I did with the nvtx. It was definitely using only those markers, nothing more. So those disadvantages and advantages are, I would say, majority in this talk will be my opinions, right? So take it with a grain of salt and maybe adjust it to your perspective. So basically, another advantage of this thing is that you can start the application. You can replace the NSys with something else. There are many other applications that will do the tracing for you. And there are ones that are like interactive, that you just, I'm not sure how are they called. You would be able to find it in the documentation, right? They will just basically start the application and forward it to the GUI and display it in the real time, right? So you can profile, for example, desktop applications like games and whatever. And at the same time, I would say the disadvantage and the major reason why I couldn't use it in my scenario, I will talk later about, is that it's the application, right, or the profiler collector, or how to call it, is a standard application you need to have installed on the system where's your application, where are you profiling the application, right? You need to kind of wrap it inside this tool. There's even a mention in the documentation how to write your own wrapper, or how to call it, this NSys substitute, but the documentation or the example is incomplete. They even stated there, so feel free to read it later if you feel so. So what's next? Next is Tracy. And
Question.
Sure.
Does this tracing provided by NVIDIA work only for GPUs, or is it like generic computing?
sorry, the NVTX is for GPUs?
Yeah, basically asking because it's in video stuff, right?
Definitely. I mean, definitely there's mentioned CUDA and OpenGL and Vulkan many times in the documentation, but since I never worked with them, I kind of, you know, ignore them. But definitely, as you pointed out, it's NVIDIA. Definitely, it works for GPUs somehow. Maybe you will need to use some other header or library, or maybe add some defines or whatever. I'm not sure. Just basically, definitely, the documentation is full of like mentions or points many times on the GPUs and CUDA and whatnot. And so
Same API for multiple platforms, including GPUs, so that it would just, I don't know, popularize their tools even among those who don't do GPU programming, maybe just for the sake of convergence. Because NVIDIA CUDA code can be written quite normal C++ way without actually having to think too much that one is running on a GPU. And maybe this thing could be just another thing to put there.
Most probably, I'm not sure. I mean, my experience with CUDA is limited to some, sorry? No, not this thing, but to one very short, like 1 semester long course on university, right? And that's the last time I saw it. So I definitely know nothing more about it. But as you said, maybe the NVIDIA is trying to put their foot in the door with, you know, or expand with, you know, providing some similar API for both GPUs and C++ and whatnot. And maybe one thing too, I just remember, the nvtx is mostly C library, and those things that I showed you are like AI wrappers around the C like function calls, right? So it's very kind of a thin wrapper around that. And so maybe that's one more thing. Then maybe that's more how to say it. That's more indicative that it's maybe already or used for the CUDA 2 or for the GPUs. Anyway, so the Tracy, very similar, right? Exactly the same example, only I only changed the include, only changed the two macros, or I guess in case of Tracy, those are macros. Maybe in the case of NVTX, those are definitely the second one was some kind of a class, you know, and the first one, the nvtx func range, was most probably macro, I guess. In case of Tracy, those are macros. You can even turn off the Tracy like implementation at compile time, you know, by supplying something like define Tracy disable or enable equals 0, something like that. Just basically, you could read that in the documentation.
Check the containment of the output files of the profiling.
Sorry, can you?
What was the data written in the profile files of measurement? How it looks like?
How it was good? Like I'm not sure if I can talk about the quality. I mean, those are like, let's say, toy examples, right? Those are very short, like time periods, and in the.
I think the question is about the format of the data.
Yeah.
Oh, the format.
Exactly, you know, representation. For example, it's a mail-like or JSON, string-based, whatever.
The representation is, in case of Tracy, binary. In case of NVIDIA, I'm not sure, but I guess it's binary too. It's somehow, I'm not sure if it's some common standard or something, but the Tracy, I will talk about this later, basically about the file formats, hopefully. And if not, please ask a second time.
If it's possible to use this format to produce the own representation. Yeah. Visualizer UI, I mean, it's just.
It seems to me that both tools, even Tracy and even NVTX, have their own formats with some possibility to probably, maybe, I'm not sure if to export the data, but definitely to import other formats. And one of them I will talk about later. But as far as I know, those are some binary and their own, like, let's say, proprietary, maybe, I'm not sure, formats. So basically very similar. You just compile it, you know, repeat until you are happy, until you have found something interesting. And then similar to the NVTX, right? You have some kind of GUI and you just need to profile or download the data from your application. And I would say the NVTX had different, as I said, you had different possibilities, right? How to save the collected data. There was the NSys that would save them to a file. There were some other options that I even didn't know, but you can look them up. And in case of Tracy, there are only two. You have this GUI and the application. And if I will return one page up, you see in the third point, I'm setting the environment variable Tracy no exit equals 1. And this means that the application should wait for the profiler to collect the data from it, and only then it will terminate. And that's how the Tracy works, because internally it starts, I guess it starts a thread, and the thread opens a connection, and it collects all the data, and the connection waits until all the data is flushed to the GUI. Or you can, the second option is that you can locally near the application on the same machine, or maybe even over network, right? You can start a command line application or tool that will just do the same thing. But you will need to, open it once again in the same GUI later to view the collected data. Basically, very, very, very similar as to the NVIDIA NSight systems. You just basically see there two stacked bars. First is the sum function, and second one is like 6 times repeated the loop range iteration or something. Loop iteration range. So once again, it's very extensive. It has many features. One of the features I was looking into was that you can use it. It has its own wrappers for example, std mutex and some other multi-threading like classes and primitives and whatnot. And it will just basically, you will use its implementation of the mutex, which is just regular mutex, like wrapped inside a marker or something. So you would be able to see in the profiler, like when was something clocked, when was something else, some other thread was waiting for it and stuff like that. So it's very nice, this possibility. Definitely, I recommend looking into that if you are interested. And what else? What I like about Tracy and what made me able to use it was that it doesn't need like another application wrapping your application, to run the profiling, because everything is compiled into your executable. And for the disadvantages, I found that it's very, maybe it applies to the NVIDIA NSight systems, right, too, but definitely it seems to me that both are not so much adjustable, I would say. And you need to, or I had to do some kind of, I had to bend it a lot to make it work in my case, and, forget about some use cases. I wasn't able to use all the features to make it work. And what else? Inability. And somehow, I don't remember it, but obviously I wrote it there, that the Tracy is unable to export the data in other format, right? I have it there. So probably I figure it out in the past.
What was the C++ that you could use in your measurements?
I mean, I guess 14. Yeah, 14 back then. And I guess the Tracy, I'm not sure if it's written for C++ 11, maybe for 17. I'm not sure, but well, at least 14 because it worked with 14. So that's it. I'm not sure of any particular features that are like a must for this profiling to work, right? I mean, it works even under C if you give up on the array, how is it called, RAAI, right? So C++ 11 only brings maybe some comfortable approaches how to do stuff. But anyway.
Question.
Sure.
So production code, like if you use Tracy, you would use the wrapped primitives for concurrency.
I mean,
and you would compile them with the define that would
remove the tracing?
Of course, that's one approach. Like exactly, like providing the define that will turn off the implementation and it will become a no-op or something like that. That's one approach. Or the second one is once again similar to the printf debugging. You will delete all the markers that you edit, right? Because, well, let's say honestly, like if you do the profiling now, you come to some conclusions, leave it be, or commit it and get it to a master or something, and you get to it 1 year later or something, it will most probably be outdated, and you will be looking at it, and you will be lost in what's happening there, right? It's, I guess, depending on the time interval, it's better to start from scratch again, right? Next time you are profiling your application, if you don't have some other use case than I had. And
pipeline like CI or something like that, where you have in parallel.
Of course, then basically, yeah, if you have some pipeline for performance measuring, that's reasonable to have it there, and switch only to define and turn off or on the implementation. And as I said, I will only mention the perf and flame graph. It just basically, I maybe already said most of the stuff, that it samples the perf samples your application. It's very similar that you need to run perf, some arguments of the perf, and then your application and arguments of your application, and it will produce some file in its format. It's, of course, it's open source, and you can read the format specification, and it can be beautifully and visually displayed via the flame graph package. There are the links at the bottom. If you will later look at the presentation, I will provide it to, I guess I will upload it to the Meetup, Discord, something. And or you can just basically find it on Google, right? So as I said, there are many more tools. I just basically, you go to your favorite search engine, you put there something like visual profiling, and it will find you many other libraries and frameworks and whatnot. So I'm getting to the what I wanted to talk about the shortcomings of those profilers that were, as I said, shortcomings in my situation, right? I was in what sense was my environment or was my setup constraint, right? It was web server. The application I was interested in, or we were developing, was web server, basically in C++, maybe obscure, but it was very old, and for, let's say, for reasons nobody wanted to, rewrite it anyhow else. So there we were. And the application was somehow interesting. There were some patterns, I would say, that after start you had to demonize it, which means calling a fork and then setting something like session ID, or what's the function set as ID. And then it did its own initialization. And what else? Then it opened, from in the initialization file or the configuration file, there was a port on which it should listen for the incoming requests, open the socket for the accepting mode, and in the loop, on the polling the socket or something, it was, just waiting for those incoming requests. And for some reasons that are, already like reasons why was it done this way, the people I have never met, and they were older than the first commits in the Git. The requests were processed in each own forked child, right? So you have your application, it receives a request, does a fork, processes the request in the fork, responds, the child terminates, and the parent still continues, looping on the socket and polling for incoming connections. And this was extremely hard to overcome with the profilers. I mean, I didn't even try NSight, because we were developing on a, let's say, private server. It wasn't back then. It wasn't like in a cloud, in AWS or whatever. It was just basically their own server that was somewhere behind few doors, and they had their own administrator. I wasn't able to install there anything, so it ruled out the NSight, and I was only able to use Tracy because, as I said, you compile everything you need into the application, and this was the only way I was able to profile it. But the Tracy is mostly, I would say, focused on the desktop or desktop application, let's say, or the application where you have like simple, how to describe it? Just basically, for example, games, right? Or desktop applications, right? Like, I don't know what else, like Blender or where just the user interacts with the GUI, or maybe can even execute some scripts and it will do the work. But definitely not this kind of, architecture we were having.
Local, you just run the app locally, and then the profiler locally, the same machine. That's what like you become dealing with, right?
That was one of
Instead of remote.
that.
Something you be able to run remote.
I mean, that's the part of the thing. And the Tracy failed in the sense that, after the fork, the internal implementation seems to me is like it has its own thread, which has its own connection with some queue. And when there was this marker, it just basically, pushes some data like timestamps to the queue, and eventually the thread with the connection will pick it up and send it to the GUI, right? And this thing seemed to me, I'm not 100% sure, but it seemed to me that this thing, when it forked, there were two identical connections to the one GUI client or something, and it tried to send the same data twice, and it crashed every time.
It's part of the process.
Yeah, exactly.
Tracy as well.
So I had to overcome this somehow. I managed to find in the documentation that there are some compilational flags, like Tracy delayed init and Tracy manual lifetime and stuff like that. And if compiled with this, I was able to manually initialize the Tracy later because it's some kind of global variable on the, let's say, file level scope. So it initializes even before entering main. And those macros were, with those macros or with those flags, I was able to postpone the initialization of the Tracy and initialize it only after the fork in the children. And if I was careful enough with where I put my markers, definitely not in the stuff that was called as part of the initialization of the application, then it didn't try to touch the uninitialized queue or connection or whatever, and it didn't crash. So this is how I somehow bent the Tracy to do the work. Just out of curiosity, because the application was taking, it was taking, I'm not sure, depending of course on the response, right? Because there was some kind of, parsing of the request. It was few hundred milliseconds, I would say. Then the external system, like translating my request to the request for the external system, it was like maybe a few seconds or something. And then, post-processing or collecting all the data. And there were many external systems, different ones.
No business needs for profiling, or
There were.
struggle with.
I mean, there was some like bad mood, constant, and not so, I would say not so, how is it called? Intense, like bad feeling about the performance of the application. So in one point, we decided to try to profile it, right? To try to figure out what is so wrong about it, right? So
Just one decided to use external profiler, while the whole task is, just creation of own files on each iteration of run. Just file and couple of timing marks.
I mean, using the profiler is how I got there, right? Because I was able to, I was, let's say, potentially able to, as I said, put some logging messages with extended with times, but the structure, to parse this thing from the log file would be very hard, and that's the work that the visual profilers do, basically, right?
It's exactly what I'm trying to say. You're describing the system where every forked application can be named with just local time, for example, right? Or even static variable from the main application, and you can just iterate it. It's a simple status on every run. It's not the task which could be, hardly demand this external usage of some tools. I see nothing in the whole scope. At the same time, just trying to understand why you start to do this. That's why.
Because I don't know, just basically, as I said, it's more basically it's just visual, right? Instead of looking at the log file, you just have those stack bars and stuff like that. Just I would say it's about the comfort of the about personal preference, right? So I guess I can skip this. Nothing important. And after having this, I would say, bad experience with the Tracy, where I wasn't able to, profile it properly, I would say, or with ease, I decided eventually, or I got idea to write very simplistic library that will do just that. Just basically collect all the tracing markers or the performance information and save it to some file, and later you would be able to open it in some kind of GUI or external tool that will visualize it, right? And that's how I got there, right? On the Discord, I announced it. I announced that I want to do this talk, and even people there, only 2 people voted in the poll, but out of 2 people that voted, 2 of them voted for, that I should talk about this library I tried to write. And so here we are getting. It's called C++ or cxxet. It's just abbreviation for C++ easy tracing, because I wanted it to I wanted it to provide easy way how to intrusively mark up the source code, right? To generate the profiling data, how to simply hand over the collected data, how to be able to somehow very comfortably and like how is it called, unambiguously overcome the forks and be similar to a Tracy in a way that everything is contained in your source code, right? And well, right now, I guess it's still very, very work in progress. How to say it? It's under development, right? It lacks documentation. If you look at the repository at the GitHub, you will see the README is only cxxet, license something, and to do, and maybe some ideas, below that. But nothing described like how to use it, how to install it, and whatnot. Hopefully, I will get to that as soon as possible. And of course, I'm doing this talk to present this to you and to collect feedback about if you find this kind of approach to, measuring performance interesting, and if this somehow appeals to you, if you find it basically, as I said, interesting, and if you have some ideas. And so just to, as I said, I put up this list of my own requirements of what should it do and how. And one of them is like the ease of usage. One of them is like to obtain the library and mark up the source code. So basically, that's it. If you use CMake, which most probably use, like in the service from Stack Overflow or something, CMake is used used by 50% of developers or something. So most probably you use it. If not, you at least know it. And if you don't use it, you probably could somehow hack this and install it somewhere else and then use it from that other directory, whatever. So basically, just fetch content, and that's all. You just link your target to this library, and you are done. You are able to profile it. And
That's like a new feature?
I'm not sure how new.
It's 5+ years now.
Okay, 5+ years, okay. Good enough.
Definitely, you on the documentation page. I'm not sure what version, but if you say 5+ years, be it 5+ years.
Just like very short about this. It's changing with basically every release because it's gaining new features. It's now capable of doing like dependency providers from external places instead of just downloading from GitHub and so on, but like this has been around for a long time.
I haven't seen it
It's
anywhere, basically. Yeah, like, well.
So-
I think anything similar, like, where you go, like, and it's a fetched dependency.
So regarding the CMake, we can talk about this later. We or you or whoever wants. So regarding the cxxet, just basically the markers, they are, I mean, once again, you have to include some header, you have to use this thing, which is like, I have compared it to the nvtx, right? Those are just different names for same concepts, right? Nothing new, I would say. Just basically you will put there some macro or something, and it will just, serve as the marker. So, and what's this about? And there's one, I would say, if you will look like carefully in the how is it called, in the nvtx documentation too, you will see there that you should, before calling the first function of the nvtx or something, you should call this init function called blah 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 foo something. And it's very same here. It's on the third line. I encourage you to eventually call this sync thread reserve function that will allocate the storage for the thread local buffer that will, just basically hold all the submitted markers.
Right. So I have a related question. How much thread local storage do you use
Per each thread one.
per each thread?
I mean, in each thread where you submit a marker, it will first go to the thread local buffer, and on the thread local, on the thread exit, it will call the destructors of those, objects, and it will, in the destructor, it will flush all the collected data to the global static non-thread local one. And this one will eventually, in its destructor, will call flush to file, let's say. This.
Those are macros, I suppose, because they.
Sure, I will. Oh, how did I get there? Sorry. I will get there. Maybe, those are macros, right? And they are starting with capital letters and continuing with the small ones.
It's fine, like, just wondering, what did you need of the macros?
Very similar to the Tracy. There's if you provide define, I'm not sure how is it exactly, something like cxxet disable or something to the compiler, it will just, everything will be will become no. How do I get there? Oh, here I am. So, and those are the macros. Yeah, this is the, I would say, best practice. You see there on the third line in the main thread, you should reserve for the thread local buffer in the main thread. Then you spawn another thread on the, I'm not sure, 5th line or 6th line. You should once again reserve in the thread for that buffer again, and then you can.
That you need to do this thread reservation for every thread.
Yes. I mean, you don't have to do it, but you will pay for the allocation in the first use of the first marker, right? Just basically this.
So don't do that. That's okay. Only the source.
Yes, exactly. It will be, I would say, suboptimal. That's only the thing that will bother you. That's the only downside. And what else? What's this? Whoa, there's one example. In the repository, it lacks documentation, but it has many examples which are not documented. And then there are many tests running above those examples and checking that it behaves like as expected. And one short snippet of one of those examples just basically does this thing. It's recursively calls itself until it reaches 0 or something. And in each call, it will just basically put there the marker, sleep for some time. So the marker is, properly, there's some nice spacing, and it looks like this, right? It will build this pyramid. This thing is the Perfetto UI. It's some web tool, and it accepts this format, which is called, how is it called? I have it on the next slide, I guess. And Yeah, and the format is called trace event format. You have the bookmarks here, down there. You have it's linked to a Google document. There is the specification of the format, and there are two variations, and I have chosen the second one, which is called JSON object format. And the advantages are definitely portability. I mean, you will just generate a trace and open it in any profiler that accepts this format. You will find anywhere, right? Even the Tracy GUI accepts it. The NSight, it seemed to me that it doesn't recognize this format, but definitely the next one was, as I said, the perf UI. There are definitely many more. And the other advantage, I would say, it's part of the portability, right? Since it's JSON, it's human readable, and if you know what you are looking at, it's even understandable. And if you pretty print it or format it, then it's definitely readable. And you can build your own tools like small scripts using JQ or something, right? And obviously, since it's not binary, it's very, very like bloated, or how to say it, right? If you collect some traces, you should how is it called? Like zip them or deflate them or something. And that's probably it. That's an example of the internal structure, right? Then you have this something like display time unit, nanoseconds or something. And then you have this trace event, which was called main, or it would be the sum function or pyramid or whatever. Then the PH means, I guess, phase, or not phase. What was it abbreviation of? I don't remember, but but it definitely means that it will mark the scope starting from the definition of the object, and when it leaves, it will in the destructor it will just mark the time. And the constructor was called in the timestamp with this time, like those 10.199, and it lasted. It's not like time point and time point. It's time point and difference, right, or increment. So it lasted for like 9,900 something, I guess, nanoseconds or milliseconds. And there's the PID and thread ID, or process ID and thread ID, and then the format, or the oh, it's not there. Maybe it's another slide. And in the format, it's like 20 pages of, or maybe 40, I'm not sure, just a lot of features and a lot of stuff you can do or you can record. And I'm using only the bare minimum, I would say, that was in the documentation. And there are many kinds of markers. Like I would say there are like 10 or 15, I guess, and I'm only using, or I only implemented like four kinds. Those are the mark duration. They are in the end result, they are equivalent to the mark complete or the complete markers. Those are just basically those long bars that that are stacked on each other. Then there are mark instance. Just basically, they don't have duration. They just mark a time point on the timeline. And then there's a counter, which by this you are able to plot, for example, the CPU usage or memory usage or something, or whatever like measurement you want. And for example, the perf UI then displays, just basically plots the graph, right, with the x-axis being time and the y-axis being the value of the counter you provided. And what else? As I said, for the visualization of the collected data, you can use the perf UI, Tracy, which can import this format. And as I said, the Chrome browser it's somehow built in. And regarding the data collection, if I wanted to make it like more simple, then how is it doing Tracy with the, as I said, with the connection, and then is doing the NSight with the external wrapper application. Just basically, as I said, inside the application there's a built-in buffer that will eventually dump it to the file, right? And already I mentioned that there's a thread local storage buffer for each thread that's submitting some markers, and this. So from each thread, from each of its thread local buffer, on the thread exit, it will submit all those collected events to the global buffer, and this global buffer in its destructor will submit it or flash it to the file. If you don't request it to do it like beforehand or sorry.
Is this memory dynamically allocated during work or it's pre-allocated?
Those buffers are like you can pre-allocate it, or there's something like I named it like something like sync thread reserve. You can say I'm expecting like 64 events to collect, right? So you will pre-allocate buffer for 64 events. And if you eventually get to the point that you will submit like 65th event, it will do something like it will allocate another chunk, and it will become a linked list, and so the amount of allocations will be, let's say, suboptimal. So, but eventually, but it won't crash. It will continue to work. And the other thing is, I just remember that, of course, if you will generate a lot of tracing data, it will all stay in the memory. So I'm not sure like your application can be in a like true constrained environment, like with limited RAM or something. And by generating many those markers, you can quickly run out of memory, right? Like you should somehow account for how much data you will generate, or this profiling will generate. And
Is it using now?
I'm using new right now. Maybe eventually, that's one of the things that like that like I plan to eventually in the future implement some measuring script or something that will, and by this, with this measuring script in hand, I would be able to, let's say, measure the difference if I change the new for the malloc and just basically, put there the data. Since it's binary data, it's how is it called, plain old data, or just basically those are just ints, right? So it's definitely mem copyable, and you don't have to invoke some non-user provided, the opposite of user provided constructors or copy constructors and stuff like that. Just basically plain mem copy is its copy constructor, right? So eventually I would be able to measure the difference if it's improvement or not. But right now it's just plain new, and it's new of the array, and it's putting or something like that. I mean, we can talk about it later. I will just finish the talk. Sorry. I'm getting into details.
In restricted conditions, that's it.
Definitely. I mean, I will try to finish the presentation, and then we can discuss it more. And what is there else? So regarding the file flushing, right? There's this function or macro or whatever. It's on the line 6 or 5. Just basically, this is some kind of, I was thinking that I will provide many more formats. It's just some kind of artifact. It will probably, I will delete this, but basically you just call this thing and you provide the file name, and the last thing is flag or the bool indicating if you want to flush everything you have right now to the file, or if you want to, let's say, defer it to its destructor, right? To the destructor of the global object or the global buffer or sink. That's one way. Or the other one is that you can provide, you can start the application with this environment variable set to the file, to the output file, and it will behave exactly the same. So this is just some, let's say, it's just for convenience. And as I said, one of my requirements was that I want to have it all contained in the compiled binary. So I guess it's obvious from the previous examples that everything is baked in the profiled application. So you don't have to install anything else. And the last, and I would say maybe the most hardest thing to talk about, is like its ability to survive in the highly or frequently forking environment application, right? So I didn't figure out how to, like I didn't think of any reasonable names for macros or how to do it with macros, right? So basically, in this case, you have to resort to the old if define cxxet enable. Then you have the code for this thing, and then you have the endif. Basically, you need to manage this yourself, and it's a bit of a mess, I would say. And this short example demonstrates how to divert, or how is it called? Yeah, divert the thread local sync to something that you define, be it locally in the scope of the function, or in your local scope, or you can put it in some of your classes or something, whatever you want. Just basically on this, how is it? What's the number? On the 6th line, you just define some file sync local variable, which is result of this function call. It will make, I guess it's unique pointer, if I remember correctly, and then you will set it has the same API. You will set the format, file name, and if it should flush all the data right now or later. And then you can use it later in this, for example, in this thread, and you will go like file sync local and divert the thread sync to this, right? As I said, every thread has its own thread local storage, and by default it points at, and by default it flushes to the global sync or global buffer. And by this function call on the 3rd line from the end, you will change the, let's say, parent of the thread local sync to this, let's say, local one, and you will receive, and it will flush all its data into this buffer, and you can then, and I guess it's on the next slide. Yeah, exactly. Then what will happen? Just basically the main thread, most probably you have already set it up to flush all its data to some file, let's say main.json or something. And then you can provide for the thread local or the file sync local, you can say flush it to the, I don't know what name, like file sync local 1.json or something. And you have separated markers from those to, let's say, execution paths to different files or different targets, let's say. I mean, it's because it stems from my frustration with the Tracy unable to handle the forks, right? Because I demonstrated in.
I thought one same file, right?
I mean, it's, well, later you can merge those files, but the thing is that like merging the files, it can be done by some very small script, like in Python or whatever, or maybe even JQ. But the thing is that I wanted to be able, I mean, I am, as I said, I'm demonstrating this principle on only a thread. But if it forks, then like I don't want to like check if the file exists, and if it does, then append to it or create it and write there my content, right? I want each, after it forks, each application should decide like, how should I behave to my already collected data? So let's say in the parent, I want to keep them, and in the child, I want to discard them or divert them, for example, to other file or to devnull or something, right?
Did you consider maybe like diverting the data to the parent? You know, like, or maybe like have like the sync, just open on the parent, and then like redirecting the collected data to that. Like say if the name's 5, or socket.
Exactly, that's the thing. I mean, in this in the current implementation, it's just basically everything. It's just pushed to some thread local queue, right? Nothing. No, I guess not.
If you're dealing with IPC, right?
Exactly, and by communicating it to other process, it becomes IPC, right? That's not what I wanted, right? I wanted to keep it like on the. I wanted it guts to be very simple, or as simple as possible, or as simple as I could think of, right? So that's the reason I would say. And as I said, I demonstrated it on the threads, but that would be the pattern that you would be able to use if you wanted to, as I said, separate the collected data from different processes that were, before that stem from, forking one in the past. Just basically that there's this short snippet of code. Like after the fork, if I'm child process, I will just basically flush everything that I have in the global buffer, or there's even the very similar method as was displayed, before, that was in the, let's say, the file local, or how was it called, local sync, something. You will just flush it to the null pointer means discard it or something, or dev null would be, I guess, equivalent. Maybe just.
But stuff to like think about it, it's like it's not like a library and like this, it's like you
Yes.
make this branch around it.
Yes, you have to exactly. You have to take care of each fork you are doing, or.
Don't you just like hide that inside your library? Like figuring this out. Like,
I mean,
implicit, like sort of deal it, like make it implicit, right? I'm doing like I want like user says, declares, well, handle my forks independently, boom, right? Or then it doesn't, right? So
maybe I can eventually get to that. I will need to, let's say, provide. I mean,
this is involved. This like the user has to know like your API, they have to like make these decisions, right? Like that, right?
you are right.
It's like
Just basically to provide my own implementation of fork that will do this internally. Eventually, maybe I will eventually get there. But definitely I'm not there, or the library is not there yet. So that's it. And what else? And one last thing about the redirection or diversion of the thread local buffers or things. Just basically there are methods or macros that you can revert this, and you can return from your local sync to the former global one, or even juggle between various local ones, stuff like that. So, and that's it. That's all I wanted to, or that's the minority of what I wanted to show you, but don't have much more time to talk about it. Maybe we can discuss it later if you want. Stuff about, I already forgot what you asked about, so please repeat the question next time. I will try to remember your proposition for providing my, how to call it, wrapper for the fork that will handle it. Hopefully I will remember all those remarks. So thanks for your attention, and now for other people if they have more questions.
I have one note first. I don't think I can send you an email.
Oh, you're right.
unless you own that example.
Well,
I think it was on the first slide, maybe.
I'm not sure, but I can do what? Where's home? No, it's not there, but maybe I can do what? Do I have?
Discord.
Yeah, it's fine. Like
You can already stop.
we just go to Discord.
I can do this thing. I can, if it will open eventually, I can go to the bottom somehow. How? This thing? No. I will scroll down just manually and do this thing. And it will go like Ruzovey, gmail.com. Yeah, that should be it. And I will recompile the PDF or something. Oh, I didn't save it, I guess.
Okay, and now the actual question.
Sure.
Do you save thread names or just thread IDs?
Only thread IDs, but in the format, there's a possibility to, as you suggest, to save the thread name. I don't have that functionality yet, but it's definitely possible in the specification of the format.
Yeah, when doing that, like it's really nice to have thread names when working with multiple threads, because then you don't have to be like, okay, the ID something. You can just be like, oh, this is the work thread, like this is the thread pool thread, and this is the update thread.
Definitely.
Nice.
So It's already the third thing I need to remember. So the email is updated. Thanks for your remark. So once, as I said, maybe in the future, hopefully I will get to implement this thing, the thread names.
Maybe like there's like it seems like there's like lots of like doing performance measurement like that. What's the most involved, at least to me, it seems like instrumenting it, right? Like putting those hooks in the code to do this, right? So isn't there a way to maybe like automate it, I can throw it in there,
I mean,
like remove it,
Like use something profiler instead of intrusive profiling.
Well, it could be like a mix, right? Like you could first do like non-intrusive, and then like convert it to intrusive, like when you identify like some places where it would make sense.
I'm not sure how to, I don't have any idea how to automate it, but as Martin proposed, just use, for example,
What they pay us for. to do this.
Well, like it seems like each LLM could maybe like help
Just
with
wait a
that.
few years, AI will replace us.
Well, well, it's not very creative yet, so like creative ideas, like will win, right?
So if I understand you correctly, the answer would be the definite answer would be just maybe use the perf, for example, right, with the flamegraphs, and you will instantly get all the whole code stack, right? But the thing is that you won't get the granularity. For example, if you want to like look into one particular function, but most probably it's again like, for example, the input loading and the file processing and the saving the results, it's most probably once again different functions, right? So most probably you will see it already in the perf
Yeah,
or in the generated report, right? But
that's
if
why it makes sense, like to split the logic, into different functions, so you can see it.
but with this thing you can go on a, let's say, lower or higher granularity, whatever you prefer. Sometimes you want to skip some functions, sometimes you want to be more detailed in one particular function, right? So you can just basically do whatever you prefer in that particular case. And the other thing is that, for example, the perf just basically samples the call stack, right? And maybe reads of some counters about whatever, like cache misses and context switches and some like stuff of this kind. And for example, the Tracy, as I said, it's very advanced in many features. And as I said, you can replace the implementation of the std mutex with Tracy mutex or something, and it will implicitly put a marker for the mutex, like you will see something like lock and unlock, maybe even acquired, or maybe somewhere in the middle, right? And you will see eventually, because the Tracy can be executed, or how is it called, run in real time. You can, for example, see that the application, like for example, first thread locked the mutex, the second one is waiting. Oh, for example, if you are looking for a deadlock, this can be very, very indicative, or it can point you in like theoretically, this can help you a lot, I would think, right? This is something that the perf, for example, the perf, I can imagine how to do this with perf.
Yeah, that's not possible.
Probably, maybe it is, but I cannot think of how.
Actually, a way of doing that would be, but this is on your Linux. It's like if you use BPF trace, you could use like you can attach to various hooks, including like the perf ones, but you can attach to syscalls. And if you attach to the lock calls, you can actually print stuff whenever you acquire a lock or when you release a lock. Well, hypothetically, you might just use the linker level overrides to get to replace functions for like obtaining locks, removing locks, and so on. You just replace it pointed to your own implementation that just does this stuff and then does the actual system call. This would be probably, and you are probably describing some tool that does it, that already does this. Yeah, I mean, like writing a BPF trace script is like 3 lines. Like you just write a print and like you just set the hook,
So it's much faster actually.
Well, you of course implement part of set as Linux on your Windows.
Yeah.
You might have to hook up something yourself.
Yeah.
I think it's also more fun finding out how to do it rather than finding out how to use somebody else's code.
You can actually use PBPF on Windows, and I know this because that project uses Sketch2 for testing, and they always complain about something.
Yeah, one more note to the BPF tracing that the locking doesn't have to call into the kernel if the lock is unlocked. It depends on the implementation. And I think I've heard that on Windows, there is like the locking works without unnecessary syscalls. I'm not sure on Linux, but basically then you lose some of the calls.
Yeah, you're right. There's usually the fewdex on Linux is trying to spin as much as it can, and then it will.
Yeah, but the thing is that the like C library doesn't even have to call footex, because in some cases when it's unlocked, then having an atomic int is enough, because you try to, there's many articles loaded, you try to increment it, and if it was 0, then you're guaranteed to be there. If it is not 0, you have to call footex and ask the system to wait. But if it's uncontested, you can, there is no
Yeah, but doesn't even the mutex in C++ standard library do this internally?
I don't know, it can.
As far as I know, this is actually done. And I was really pissed at some guys who were feeling like how great they are with their mutexes, and basically their implementation seemed like just hand cooked something that was already in standard library.
Maybe I have a stupid question, how it's going to work with coroutines?
Sorry,
Coroutines?
I mean, regarding the coroutines, I don't have direct experience with them. I only attended, I guess, one talk by you, and that's all I know about coroutines. But I guess the behavior or handling of this library would be very similar to the like handling it around the edges with the threads and with the fork, right? You will need to realize, like, if you want to separate the collected data from two coroutines that are running on the same thread, you would definitely need, when entering or leaving one coroutine, to set the parentsings of the thread local one to the respective ones, right?
Yeah.
So I guess it would be possible with the, and definitely if so, then with the same API that's there for the threads, forks, and whatnot.
Just time spent in a function, you do a coroutine and you just suspend it and you just get total time while it's in this
I see.
function. If it is a coroutine, you count also the time while the coroutine is suspended, which, well, this would give you like different data. Data probably wouldn't be useless, but it would just not give you exactly the data you expect sometimes.
No.
And speaking of mutexes, don't use mutexes with coroutines unless it's like just one function call from a coroutine to suspending with a mutex, or even worse, suspending a mutex while you have the coroutine can be run on one of several threads. That's the worst thing.
Okay, so that's the thing that I forgot. Maybe the most interesting thing about coroutines, that, like, as you mentioned, like having the, let's say, the marker on the top and suspending or something in the middle, right? You would definitely need to think
Before you every call away?
I mean, as I said, I mean, I don't know the coroutines in depth. I don't know more than was in this talk, and I already forgot more than half, I would say. So I guess the answer is I don't know in the end. I guess it can get to some point that it's usable with coroutines, but then it would need to be done by somebody else who knows coroutines, or I would need to learn them and implement it. And right now, I changed my answer to I'm not sure how to handle coroutines with this. So, and it was not a stupid question, definitely. Thank you. So
You were describing that you needed this performance tracking tool in a way that it works with fork, right?
Exactly.
On the other hand, if you are doing something with fork, I don't care about performance because generally, just if you just try and start multi-processing stuff, it's usually what you do if you don't care about performance.
I mean, I didn't like the fork either, but still I wanted to figure out, like, it wasn't like optimizing the application that runs for like 100 milliseconds and trying to, you know, push it down to, let's say, 80 or something. It was more like it was as I said, it was a web server, and the request lasted, or the generating the response lasted from like, let's say, few seconds, even to tenths of seconds, right? And I wanted to have visually like displayed where's the time spent, right?
You basically found the book, had the suspected there was a bottleneck and you needed to locate it.
Exactly.
Okay.
And this was my, let's say, this was my preferred way how to try to approach this.
Have you maybe considered like using different tools for this?
Only the Tracy, as I said, I described it how I had to, you know, adjust the Tracy to partially work in that environment, and that's all I tried back then. And you know, the Tracy I got to some extent, you know, to a conclusion that I was happy with. So then I left the macros, or I turned off the Tracy compilation, so it became no op. And later, you know, when I was thinking about like what to do, this is what I came up with, right? Like to write this library that in that case would be easier to use and more like I wouldn't need to, you know, as I said, kind of bend it right to my use case. So
because it's like it's an online system, right? You know, like it's a web server, you know, like on in different languages, like, you know, say Python, like you can use SDKs, you know, that hook to crash and link tools and application performance monitoring tools, you know, so like maybe using Sentry or, you know, something like that, and just, you know, like, you know, using spanning, you know, inside of it, you know, like you could use, you know, that, you know, to see how much time was spent in different parts of the app. You know, like,
I mean, I could read off from those some kind of charts. I like that. Of course, there was some kind of FHD something that was having some PHP script or something. Then it processed the request, handed it over to this application. But for this application, I only had like, I don't know what, like it started at this time and lasted this long, right? And I wanted to know exactly, like with higher granularity in more detail. So that's the reason why I employed this approach. I mean, I would say, or maybe it already, you know, many people already told it, there are many tools that can do similar thing in a different way. And I would say in the end, it's up to your preference. How do you want to approach it? And Tracy was my approach, and this cxxet was something I wish I had back then. So, any more questions? Maybe.
You completely out at the same time. Nothing of the other except own observations.
Okay. So I guess thanks for your attention, for your questions, discussion. And I will need to remember the proposition of how I should enhance the API, so I can at least write it down somewhere and maybe do it in the future. So thank you very much.